Hello, everybody. So, in today's lesson, lesson 3.2, our topic is place value of decimals. And our essential question that you should be able to answer by the end of our lesson is how do you read, write, and represent decimals through thousandths? We are on page 113 of the fifth grade Go Math textbook. So, let's get started with Unlock the Problem. The Brooklyn Battery Tunnel in New York City is 1 and 726 thousandth miles long. It is the longest underwater tunnel for vehicles in the United States. To understand this distance, you need to understand the place value of each digit in 1 and 726 thousandths. Okay, in other words, we don't read this number as 1.726. Okay, that doesn't give it any value. So how can we do this? Well, you can use a place value chart to understand decimals. Whole numbers are to the left of the decimal point. Decimals are to the right of the decimal point. The thousandths place is to the right of the hundredths place. So let's look at our place value chart here. So everything to the left of the decimal point are whole numbers. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, so on, right? Everything to the right of the decimal is less than one whole. And we start at the tenths. Hundredths is to the right of the tenths, and thousandths are to the right of the hundredths. So in the number that we were looking at, we had 1, then the decimal point. The 7 is in the tenths place. The 2 is in the hundredths place. And the 6 is in the thousandths place. So in order to read that number, we look at the digits to the right of the decimal point, and you read it with the value of the decimal value to the farthest to the right. So in this case, we wouldn't say 1 and 726 tenths. Okay, because the 6 isn't in the tenths place. You also wouldn't say 1 and 726 hundredths, because again, 6 is not in the hundredths place. So the last digit is in the thousandths place. So you would read it as 726 thousandths. So whatever the last digit is, whatever place value it is, that's how you name it. So in expanded form, so this is standard form, 1.726, 1 in 726 thousandths. This would be its expanded form. How many ones do we have? We have one set of ones. How many tenths do we have? We have 7 times 1/10. That would be its value. 2 times 100th, and 6 times 1,000th. And so what would those values look like with decimals? Well, 1 is just 1.0. 7 tenths is 0.7. 2 hundredths is 0.02. And 6 thousandths is 0.006. All right. So the place value of the digit 6 in 1 and 726 is thousandths. So the value of 6 in 1 and 726 is 6 times 1/1000th, or 0.006. So standard form again, 1.726. In word form, we would say 1 and, so the decimal point is always read as and, unless there aren't any whole numbers. So let's say the digit to the left is 0. Well, we wouldn't say 0 and, we would just read the decimal value. But in this case, we do have a whole number. So we would say 1 and 726 thousandths. And then expanded form, we've talked about that. So we're going to be practicing that. So let's look at the first one. Use place value to read and write decimals. So the standard form of this number is 2.35. Well, how do we say that? Well, to the left of the decimal means we have two whole numbers. We read the decimal as and. So 2 and then we have the decimal value. So let's just write the decimal value. It's 35. And what's the place value of the digit to the far right? Well, the 3 is in the tenths place and the 5 is in the hundredths place. So it would be 2 and 35 hundredths. Okay, expanded form. 2 times 1, the value of 1 is 1. Okay, plus 3 times 1/10. Okay, we have 3 1/10ths plus 5 times 1/100ths. Okay, we have 5 1/100ths. All right, let's look at B. So this time they gave us the word form, 3 and 614 thousandths. All right, so 3 and, so that means we have 3 whole numbers. 614 thousandths. What would that look like in expanded forms? Well, the ones are worth 1, so 3 times 1. The tenths, the 6 is in the tenths place. The 1 is in the hundredths place. And the 4 is in the thousandths place. All right, so let's keep practicing. Page 114. All right, so the example, let's use the place value chart. A common garden spider spins a web with its silk that is about 3,000th millimeter thick. A commonly used sewing thread is about 3/10 millimeter thick. How does the thickness of the spider silk and the thread compare? So we have something that's 3/10 compared to 3/1000ths. They want you to compare the thickness. So let's write those numbers in the place value chart. So our first one, there aren't any ones. There's 0 in the tenths place, 0 in the hundredths place, and 3 in the thousandths place. So 3 1,000ths. In the other one, we have 0 ones and we have 3 tenths. Okay, so count the number of decimal place value positions to the digit 3 in 3/10 and 00 and 3,000ths. 3/10 has 2 fewer decimal places than 3,000ths, right? If to get to the 3 in the first one, we have to go 1, 2, 3 place values to the right of the decimal. And to get to the 3 in the second one, we only go 1 place. So it has 2 fewer decimal places than 3,000ths. So how much is that worth? Well, 2 place values would be 10 times 10, or 100 times. So 3/10 is 100 times as much as, or 100 times bigger. And we could also say that 3,000th is 1 1,000th. I'm sorry, 1 100th of 3/10. So the thread is 100 times as thick as the garden spider silk. And the thickness of the garden spider's silk is 1 100th that of the thread. Okay, we can also use place value patterns to rename a decimal. So let's look at this one. So we start off with 0.3, okay? 0.3. We're just focusing on the blue 3. Well, how much would that be? That would be 3/10. And we'd say 3 times 1/10. This next one, we have 2 digits to the right of the decimal point. We have the 3 and the 0. We're just focusing on the blue. So we'd have 30 hundredths. So we would write 30 times 100. 100ths. And then the last one, we have 3 digits to the right. And so that would be 300 thousandths. And how do you rewrite that? That would just be 300 times 1 1,000ths. All right, we'll continue on page 115. Let's look at number 1. So complete the place value chart to find the value of each digit. So we have 3 and 524 thousandths. 524 thousandths. So its value is, the ones are 3 times 1. The tenths would be 5 times 1/10. The hundredths would be 2 times 1/100th. And the 4 would be 4 times 1,000. So how do we write that as a decimal? Well, the 3 times 1 would just be 3.0. The 5 tenths is 0.5. The 200ths would be written as 0.02. Remember, if you write 0.2, that's not 200ths. That would be 2 tenths. So we have to have the value of the decimal correct. So 200ths has to be 0.02. If we wrote 0.20, that wouldn't be 2, that would be 20. So remember what the number we have. Okay, 4 thousandths. Again, I wouldn't put 0.4 because that would be read as 4 tenths. I wouldn't put 0.40 because that would be read as 40 hundredths. I wouldn't put 0.400 because that would be 400 thousandths. So I need a value of 4, which would be 0.004. Okay. All right, so write the value of the underlying digit. So we have no ones. We have 5 tenths. We have 4 hundredths. And we have 3 thousandths. So what's the value of the 4? Well, 4 hundredths. Or you could just say 0.04. Okay, how about number 3? 6 and the first digit to the right of the decimal is the tenths. So 2 tenths, 3 hundredths, 4 thousandths. So 2 tenths. So 2 tenths, or we can say 0.2. Okay, number 4, 3 and 954 thousandths. The 9 is in the tenths place, the 5 is in the hundredths place, and the 4 is in the thousandths. So we'd have 4 thousandths. And we can also write that as 0.004. All right, write the number in 2 other forms. So this is standard form. So it's word form. We have no whole number value. So let's just read the decimal value to the right of the decimal. So we're going to say 253. Okay. 253 what? What value is the 3 in? It's in the thousands. So 253 thousandths. All right, expanded form. We have 2 times 1/10 plus 5 times 100th plus 3 times 1,000th. Number 6, standard form is 7 and 632 thousandths. So word form, start with the whole numbers, 7. Decimal point is read as and. Read the digit to the right all together, so 632. And what is the place value of the digit to the far right? The 2 is to the far right, and that would be in the tenths, hundredths, thousandths. So 32 thousandths. Okay, write it in expanded form. We'd have 7 times 1 plus 6 times 1/10 plus 3 times 1/100th plus 2 times 1/1000th. All right, number 7. Write the value of the underlying digit. So we're in the tenths place. 9/10. The 4 is in the tenths place. The 9 is in the hundredths place. The 6 is in the thousandths. So we have 9 hundredths or 0.09. In number 8, the 2 is the ones place. The 7 is in the tenths place. The 2 is in the hundredths place. And the 6 is in the thousandths place. So we have 7/10, which we can also write as 0.7. In number 9, we have 1 in the ones place, 0 in the tenths place. The first 6 is in the hundredths place, and the last 6 is in the thousandths place. So we have 6 thousandths. How else can we write 6 thousandths? 0.006. Okay, number 10. 6 is in the one place, 3 is in the tenths, 9 is in the hundredths, the second 9 is in the thousandths. So we have 3 tenths or 0.3. Okay. We have 0 ones, we have 0 tenths, 0 hundredths, and 2 thousandths. Or 0.002. And 14. We have 1 in the tenths place, 4 in the ones place, 3 in the tenths place, 7 in the hundredths place, and 1 in the thousandths place. So we have 1,000th or 0.001. Okay. Number 13, 14, write the number in 2 other ways. So here we have standard form. So what would it look like in word form? There aren't any whole numbers. So let's just read the digit to the right as one full number. So we would say 489 and what digit is the furthest to the right? The 9, and that's in the thousands place. So 489 thousandths. Write it in expanded form. So we'd have 4 times 1/10 plus 8 times 100th plus 9 times 1,000th. Okay, number 14, standard form, 5 and 916 thousandths. Word form, 5 and 916. The 6 is in the thousandths place, so 916 thousandths. Expanded form, okay. Well, let's start with the ones. 5 times 1, that's the value of the 5. The 9 is 9 times 1/10 plus 1 times 100th plus 6 times 1 1,000th. Okay. Okay, page 116. Number 15. Use table 15 and 16. Yeah. Use table 15 and 16. Use the table for 15 and 16. So we have an average rainfall in meters. And so we have California, New Mexico, New York, Wisconsin, and Maine. And their values. So only New York and Maine average more than a meter of rain per year. The other 3 states are less than 1 meter per year. So what is the value of the digit 7 in New Mexico's average rainfall? So let's find the 7. Okay, so the 7 is in tenths, hundredths. So 7 hundredths, or 0.07. Which of the states has an average annual rainfall with the least number in the thousandths place? What is another way to write the total annual rainfall in this state? Okay, so we're looking to the thousandths. That would be the third digit to the right of the decimal point. So here we have a 4, a 2, a 1, a 0, and a 4. So Wisconsin has the smallest digit in the thousandths place. So how can we write that number? Well, you could write it as in its expanded form, or you could just say word form. So 820 thousandths. Okay, number 17. Damien wrote the number 4 and 23 thousandths as 4.23. Describe and correct his error. Okay, he didn't include the 0. Okay, he should have had a 0 in the tenths place. So it should be 4.023. Okay, because right now this is just in the hundredths. Okay, so he doesn't have a digit in the thousandths place. So the 3 needed to be in the thousandths place. All right, and 18. Dan used a meter stick to measure some seedlings in his garden. One day, a corn stalk was 85 hundredths meter tall. A tomato plant was 850 thousandths meter. A carrot top was 85 thousandths. Which plant was shortest? Okay, well, often when we compare, we want to have the same number of place value digits. So on this one here, the 0.85, I could add a 0 to it, okay, to make sure it has 3 digits. I didn't change the value of the 85, okay? I just put a 0 in the thousandths place. Well, that matches the tomato plant, right? Well, the carrot top doesn't have any tenths. These both have 8 tenths. So if we're just comparing left to right, okay, the further we get to the right, the smaller the numbers, or the smaller the value. So the tenths are both 8. This one is 0 tenths. That has to be the smallest. So the carrot plant was the shortest. Explain how you know the digit 6 does not have the same value in the numbers 3.675 and 3.756. Okay, so in 3.675, the 6 is in the tenths place. So it has a value of 6 times 1/10, or 0.6. While in 3.756, the 6 is in the thousandths place. So it has a value of 6 times 1/1000th, or 0.06. Basically, they are in different place values. Basically, they have different place value positions. All right, and number 20. What is the value of the underlying digit? Mark all that apply. All right, so we have 0 ones, we have 5 tenths, 8 hundredths, 9 thousandths, 8 hundredths. Okay, well, that's not 8 hundredths, that's 8 tenths. This is 8 hundredths. 0.08, I would read that as 8 hundredths. 8 tenths, that's not 8 hundredths. 8 hundredths. It wouldn't be 8 times 1/10, it would be 8 times 100ths. Okay, so it's just those two. All right, so that's it for lesson 3.2. In our next lesson, we're going to be comparing and ordering decimals. So until then, I will see you soon.